말레이시아 저게 걱정. 말레이시아 저압도 한다.
저압도 한다고요?
저압전 트레이 위에 얹어.
전번에?
그거 왜 거기다 올려?
그치.
좀 없애는 추세라고. 그래서 점검할 때 이걸 들고 하다가 그러니까 18경감마다 하나씩 그거는 빼놓고 하고 나중에 한 방에 올라가죠. 그거 타고 올라가서 위에서. 그러면 서보로
이거요? 그거 돼 있는데?
마이크를 찾을 수 없음이라고 나와 있는데.
마이크가 없어요, 이거.
예. 그리고 소리는 지금 안 나는 상태로 바꿔놨어요.
그렇지.
어디요?
저기,
아, 있구나, 있기는. 예.
저거 어떻게 들어가냐?
여기도 있네. 요
스플래치고. 있잖아요. 보내권이. 오늘따라 차가 무지하게 다니더라고. 있잖아요. 그 지장 있는 그지. 아저씨. 쟤 또 왔나? 계속 들어오고 있어. 나 미안해 죽겠어. 얘요? 저속 다닐 때. 여기 고속도로는 괜찮은데. 한 5km 나오고. 차도 5km 나오고. 차가 무거워. 이치. 흘리고. 이거. 조용하지. 조용한 건 좀. 전번에는 우리 회사 앞에 넣었는데 거긴 리트당 700 얼마예요. 깜짝 놀랐어. 아, 그러니까 우리 막 데모하다가 테스트하다가 야야 빨리 넣고 가자 그러고 했는데 12만 얼마가 나온 거예요. 갑자기 왜 거의 10만 원 정도 나오거든요. 근데 12만 원이 더 나온 거였어. 이거 뭐야? 그랬더니 딱 보니까 1,700 얼마야. 야, 여기 이 주소는 또 뭐야?
거의 뭐 물 들어왔을 때 넣으신.
네.
엄청 많이 들어.
4,690 달려갔고요. 평균 연비가 7.8.
4,000km밖에 안 돼.
지금 18,900. 이게 만 킬로인가? 그때 받았거든. 전. 아니에요. 뭐 팔 일이 그렇게 많지는 않잖아요.
근데 이제 생각보다 키로수가 빨리 오고.
10개월인데요? 집도 아직 코앞이고. 가봐야 뭐 저기 대전 쪽. 이 근처에.
Assalamualaikum, Cik Faris, Cik Fazli, semua. Hai Jimon. 안녕하세요.
Raining.
Ready?
Yes.
Yes.
Oh my. We can still proceed for demo?
Yeah, we can do that.
Good.
Waiting.
Okay, we wait a few more minutes, yeah, for the
Yeah,
others
no
to be
problem.
ready.
5% 남았어요.
Okay.
No problem.
Yes, can. No problem.
예.
간다, 야.
Meanwhile, both of you can
있습니까?
watch my
오,
the beautiful face.
네.
몰랐어. 아, 있었구나. 아, 예, 됐습니다.
그지?
예,
아,
없는
나이스.
줄 알았어.
이제 문제 없지?
예. 아,
아니, 당구에 뭐가 있는지도 몰라.
Yes, live from Korea.
아, 씨, 나간다 했잖아. 고 20볼트에 좀 충전은 되고 있어?
예, 되고 있습니다. 분 남았다고 풀 차지하는데.
야, 이거 걱정 없네.
예, 맞습니다. 아, 그럼 제 차에서도 충전하면서 뭐 할 수 있겠네요.
이런 게 있어야 된다니까, 이런 거. 얘가 60몇 충전은 이런 게 있어야 돼.
Okay, 3 o'clock ready.
폴백 떠놓으신 거예요?
Good afternoon. Assalamualaikum. Good afternoon. 안녕하세요.
아, 네.
Waalaikumsalam.
다 변패.
Okay, actually,
있어.
저는 그 뭐지?
the reason for us
그쪽이랑
having this
있거든요.
meeting is
여기
actually
찌간장에다가 그런 단자 같은 거 꽂아가지고.
for in this to highlight or to present
얘도 와줄 수가
on
있어.
text,
네.
thermography and analysis and diagnostic,
예.
right? Okay,
65와트.
but it is
그게 아니면
also
충전 되지 않나요?
a platform for
아예 안
us
돼요?
because I haven't met my work group, this CBM work group, for so long actually.
네.
I think I'm almost a year or maybe more than a year already.
So long, that long.
Yeah, I think, and then because usually when we have our work group, we would be able to go do any what you call it, some sort of work together, and of course the camaraderie is reflected when we have our the what you call it, the discussion and also enjoying good food among us actually. So the enjoying of the good food is being missed here actually. But again, this is a good platform for us to meet because I realize that there are also new faces in the work group, but it's okay. We can just continue this on this platform. Okay, so with us is actually with me is Fazli. Okay, and we have all our work group member, CBM work group member from all over Peninsula Malaysia in TNB. Okay, so we are looking forward to your presentation actually, and then of course we will have question and answer. And I think most of us would like to know more on your ultrasound device, ultrasound detector actually. What is your latest ultrasound detector, what you call that, version at the moment? Okay, so I think with that, I will pass it to Kamarul for the introduction and we start with the presentation.
Okay, terima kasih Pak Faris. Okay.
Assalamualaikum semua dan selamat petang. Okey, tujuan hari ini kita ada presentation berkenaan dengan tomografi, auto analysis, diagnosis sistem. Okey, yang mana benda ni kita akan dipresent oleh Encik Jimon lah. Daripada Korea secara live daripada Korea. Okay, so saya akan minta Encik Jimon teruskan. Okay, sebelum tu saya introducekan dulu Okay, Encik Hafiz Encik Hafiz ni kita punya general manager lah untuk Click Network. So, Encik Jimon. Jimon. Yep. Yeah. You can proceed for the presentation.
Yeah, thank you. Okay. Thank you, Mr. Faris and Mr. Fazli. Thank you for so, let me introduce
Hello.
let me introduce okay. This is here on the vehicle. So the mounted already here. So we will show you the our feeder line here, the back there. So we will follow the feeders around 10 minutes and show you the how it looks like and how it works. So let me introduce the task. So ready?
안 나갔습니다. 이거 지금 파일. So just a second. Oh, I'm just preparing for the slide right now. So please give me a second for the presentation. 보이시나요? So hello, my name is James Choi. I'm in charge of overseas sales of the TADS. I really appreciate for your time and your consideration today. So yeah, so let me start to have a presentation with your gentlemen. All right. So first, I'm gonna explain like table of content first. First, I'm gonna explain status, and then second, system development details, and third, development progress. So status. So in South Korea, the quality of electricity have been improved over the time, as you can see in the figure left. So like this SAIDI value have been exponentially decreased over the time, which means power quality is also have been improved as well. Even the SAIDI value 9.61 degree is like lowest value even in comparison to the developed countries such as Germany and UK and United States, etc., etc. So how Korea managed to improve our electricity quality over the time? So this is very simple because Capco it is only company who distribute power supply to the Korea have invested a lot of money and time and resource to improve their power quality in South Korea. So as the number of electric distribution line have been increased, accordingly the outsourcing costs have been increased as well. So they have invested too much, quite a lot. Sorry for that. So here is the way they used to inspect power facility like before. So there was like two people required for inspecting power facility before, and then one is driver and what the other one is inspector. Those two people as a one group, they need to get to the utility pole and then get up the car and then take a IR image by using infrared camera and then bring this image to the analyzer and then let them analyze at those data one by one, all one by one. There are 9 million utility distribution line in South Korea. Can you imagine how much like time and money like and people to inspect and analyze all of data every year? Anyway, so even though Capco have invested a lot of money and time and resource, there is like still a problem for this procedure. So here is two procedure like so those like inspecting procedure, this data in general is very subjective because inspector and analyzer rely on individual ability like skill and training. So depending on who inspect a facility and who analyze the data, the data is very subjective. So which means there is like high possibility for people to judge like any facility in a wrong way. So human error caused by human error. So in order for us to solve this problem, like human error and uh, spending too much time and energy and resource, in order for us to improve this, solve this problem, we developed TADS in cooperation with Capco. So yeah, first, what TADS can do in comparison to existing technology is reduce diagnosis cost and time, and second, it can minimize human error, and then third, it also can improve diagnosing convenience. Uh, inspector don't no need to expose their body outside of the car anymore. You can just inspect it inside of vehicle while driving, non-stop inspection. So so let me explain system development details. So in here, I want to explain first a software and algorithm of the TADS, which is most essential thing among the any other aspect. So normally, if inspector inspect all of like distribution line utility pole in their district, they need to bring this data to analyst. And then when analysts receive the data looks like this original image in the left in the left picture. All of data look like this. So can you tell which part is overheated part? No one can tell any part that is overheated because like basically color is same, but by using our auto analysis software, we can transform sorry for that, we can transform those images to this optimized image in the last picture. So how it works? So we this original image goes through binary scanning and grid analysis, and so that this software calculate every temperature of a pixel to determine acceptability. And then if there is some pixel that is not acceptable for our standard based on our criteria, our software can extract those overheated pixel and then make a image make a optimized image looking like this in the last image. So obviously, like even beginner or even non-expert, even just like random people can recognize which part is overheated part in the optimized image. So so this our solution is designed for non-expert and just non-expert, not for the expert, because thanks to our software and algorithm, yeah, it enabled them to do that. So you may wonder what criteria we adopt to use for our TADS solution. We adopt to use Neta, and then as well as our like little revised criteria established by the TEPCO over 20 years experience. So and then like if you get obtain all of data in your district, you need to bring those data to the auto analysis software and then register. First, we need to register these all of data in software, and then after that, analyze it, and then this our software gonna classify all of data as normal, like caution and warning, within just like few minutes. And then after that, for the more precise analysis, user have to analyze less than 10% of data by just drawing ROI and then like 3 page comparison analysis. And then after that, after analyzing all of data, they can database all of data in our softwares. And then after that, we can create 3 type of reports, general report and individual report, etc. So like in this after this presentation, I'm gonna actually show you how it works. Yeah, yeah, in real time. So yeah, let me explain more in later. So it is comparison with sorry for that. So it is a figure that compare those two existing technology and TADS. So existing technology was conducted manually, but TADS is conducted by automatically. And the reliability of the existing technology is 61.8%, but TADS 99.9%. And then analysis speed of the existing technology is 100 sheets per hour, but for the TADS, it is like 10,000 sheets per hour, which is like 100 times faster than existing technology. And then we also conducted a field test over there. So detection rate is quite outstanding in comparison to outsourcing. So which is like our TADS can detect like 2 times more defective component in comparison to outsource existing ways, existing technology. So and then as you already saw that this is like hardware part of the TADS. So in a like in the truck on there is like measuring unit on top of the anti-vibration unit, and then there is inside of this there is IR camera and GPS, and then here like you can just like control the can tilt inside of the vehicle while driving, and then take a IR shot while driving. You can inspect it while driving. That is yeah. Then let me explain key feature of a hardware part. So also when you just when driver drive and then inspector inspect by using our TADS solution. Once inspector take a shot of the IR take a picture IR picture of the facility, this our diagnosis software automatically judge whether or not it is defective or not. And then so when you find defective facility, our software also knew the GPS coordinates so that you can just later send maintenance crew to the facility so easily, and then you don't need to stop the vehicle to get more clear IR image. It is non-stop analysis and diagnosis, and then you can control obviously control pencils inside of the vehicle, and then you can also check real status of the facility in real time, and then when you find defective part, you can this diagnosis software go off alarm call so that like inspector can notice. So here is a comparison with existing technology in terms of like diagnosis system. So for the existing technology diagnosis, it is conducted by manually, and then for the TADS, so obviously we need to control pen tilt or and then take a IR image manually, but also diagnosis software can automatically analyze that as well. So that's why I call it manual and auto diagnosis combined. And then detection method is like for the existing technology, manual detection after stopping vehicle, but the ADS is non-stop non-stop solution. And then existing technology can inspect 400 location per hour, but for the TADS, since it is non-stop inspection, so it's 3 times faster than existing technology. And then like for the existing technology, inspector need to expose their body outside the car sometime, but for the TADS, it is in-vehicle diagnosis, so it guarantee inspectors safety as well. So we conducted a field test of the diagnosis system, but for the time issue, so I'm gonna skip it. So yeah, so seems like we have to actually operate our system for the online demonstration today. So let us start to inspect facility so that you guys can see how it works, how we inspect facility, and then how we analyze all the data we've obtained from this online demonstration, how we analyze by using auto software. So right now we are just like driving to some points that we can prepare for the demonstration. Just let us have some second. Thank you for listening my presentation. If you have a question, you can ask any question right now or later after demonstration.
Question from your side, Iksan? Question.
Hello. James Joy. Hello, James Joy.
Yep. Hello. Just second.
Okay, I'm inside.
Oh.
I'm inside. Okay.
Also.
I just want to ask about regarding about the solar gain and also the this software already calculate kind of. I mean, is it part of part of
Oh, just second for my just window. I couldn't see you in here. All right. So your question is like calculating all the data. So our analysis software can calculate.
Can I see that?
Oh, just second. My software. It is my first time to use this web some conference application. So all right. So can you say that again, please?
James, I think what Iksan trying to ask, will this system compensate for the call again, other what you call that, reflection when you measure your infrared thermography?
Oh yeah, all right. So yeah, that is a really good question. So you may wonder like how our solution can inspect even though it is like metallic object that reflect all of radiation from another object, right? So like basically our distribution line utility pole consists of 3 type of material. One is like ceramic and polymer and metallic object as well. So except metallic object, those two, ceramic and polymer, has high emissivity, which means it reflects less amount of radiation. so like 0.95, yeah, approximately. But for the metallic object, this utility pole has some parts of metallic object, but normally it is there is like tiny like very thin layer of the dust or foreign substance which covered those facilities. So even though it is metallic object, because it is covered by dust or foreign substance, so it just like it just can increase the emissivity of the metallic object, to simply put. So yeah, it doesn't reflect a lot of like radiation as you saw. So let me show the any like material for the radiation or reflection issue. Yep.
Sorry. James?
Yep, you can ask. Yep,
Okay.
I'm here.
Is it all that to input all manual?
Oh, like input manually.
Again,
Oh, so like you don't need to type any emissivity one by one depending on facility you're inspecting. So we use like 0.95 emissivity as in general as a for the facility, because there is some reason for this. So let me explain this. Is it okay for you? All right. Just a second. I couldn't find any screen share button in here, so just like oh. The- All right, can you see this presentation slide that I'm preparing for? So in here, as you can see, like there is a various type of component in the utility pole in South Korea, and all of the component like consists of ceramic and like suspension insulator polymer and cutoff switch ceramic and cutoff switch polymer, like polymer or ceramic, etc. Sometimes like metallic object as well. So for the material like ceramic and polymer, you don't need to worry about reflection because like it has a high emissivity, so it doesn't reflect that much radiation. So you don't need to care about this. But for the metallic object, even this slide, it is also covered by a very thin layer of the dust or foreign substance. So practically, theoretically, a metallic object emits less radiation and like high and but practically it just emits almost same amount of same amount of like radiation as much as just normal objects emit.
James, based on what is the smaller object that I can measure? And then whatever I mean for
말하고
you,
있어가지고 예.
and then
Oh, can you say it again, please? Sorry for that.
Yes, did
James, James.
Yeah, yep. Sorry for that. Can you say that again, please? Sorry for that. I'm really sorry for that.
Okay. What is the smallest object that I can measure with a thermal imaging camera? And then for this kind of camera, can you elaborate for us about the FOV and IFOV? I mean, so for internal field of view.
All right,
And then,
all right. So for the like FOV, 24 and 18.
24, 18. So
Yeah.
you need
Yep.
10
24 degree and 18 degree. So it is a proximity. So 24 point something and 18 point something. Did you get it? And then for the
Okay.
IFOB, and it is 0.7 milliradian.
Pardon?
Zero IFOB.
Okay. Okay, right?
Did you get it? IFOB is 0.7 milliradian for our camera. IR camera.
0.7.
What did you say?
0.7.
Yep.
Oh. Okay.
Because like we use our camera mounted in our system is like 640 and 480 pixels. So because there are a lot of pixels in like considering it is IR camera, so that is why IFOV is quite like smaller than you thought, I guess.
I mean, IFOV better is less small. The small is better.
All right,
So you can get a detail.
all right, got you.
Ay.
Is there any other question?
Okay, hi James.
All right. Hello.
Hello James. Nasro here.
Oh, Nasmul. Hello,
Yeah, Nasro. You can speak Nas.
Nas. All right. Glad to
Okay.
meet you. Well, I couldn't see your face in the like in a
Oh,
presentation. All right. That's
I
fine.
just
That's
a
fine.
normal person.
All right.
Okay. James. May I know your thermal sensitivity? Your set camera?
Oh, emissivity, you
Because
mean?
no, your camera, your thermal
Oh,
sensitivity.
sensitivity. All right.
Okay, because normally in Malaysia usually we scan at the night.
All right.
Okay, because the object and the ambient temperature is too different.
Yep. I got you.
Okay, so we clearly can capture the image, but when the object in at the background, when the behind have a tree or like building or something, so the image, the object normally quietly same with the building, so we cannot capture the image clearly.
Oh, because of
So
like
we
a tree and building or
yes
something block the image,
yes
object. That's why. So, so you wanna know how we solve this problem? Is there any
yes
any
yes
technology that to overcome those issues?
yeah so we want to know how your thermal sensitivity, because the smallest one is very good.
Oh, I smallest one. All right. So let me just like have a second. 0.2 0.5 50 millikelvin for our sensitivity, like thermal sensitivity for our camera.
Oh, 50.
Yep, 50. 15.
Oh
50. Sorry for that. Sorry for causing confusion. 50.
yeah oh not 30 eh?
All right, yeah. 50, yeah.
Yeah, normally 30 is very clear.
30.
Below than 30. Yeah, below than 30. So then the second question is how far your camera can detect the smallest object?
Smallest object. How
Yeah,
our system can
how far?
inspect.
Okay. From your the experience, how far you can detect the
How
object?
far? All right. How far our system can inspect, measure,
Yeah.
an object in like. All right. So if overheated part is small, it can inspect object within 30 meter. But if overheated part or facility is big enough, it can inspect object within 50 meter with
50
by using like 25 millimeter lens.
25 lens. Okay,
So
okay.
like there is another option of like for the solution, which is like 50 millimeter lens. In that case,
Mhm.
like inspectable distance can be double, like 60 meter to 100 meter, depending on size of object or overheated part, size of the overheated part.
Mhm. So normally you scan what time morning or the night?
During the night or during the day. So we recommend a user to inspect power facility utility pole during the night because it minimizes a possibility that that a
Mhm.
facility get affected by sunlight or reflection or
Mhm.
any other third effect. But during the
Mhm.
night, there is nothing we need to consider about like
Mhm.
emissivity or any other third radiation effect. So that's why
Oh.
we recommend a user to inspect and operate our solution during the night.
Mhm. Okay, okay.
Any other questions?
All right.
Hi. Hello.
Hello.
Hello. Hi, Mr. James.
All right.
Hi.
Yep.
Okay.
Sorry. Yeah. Yep. Keep going. Go
Hi.
ahead, please. Sorry.
Okay. My name is Amirul. So
Hi.
I only want to ask one question.
Hello,
Is it
Amirul.
true that your vehicle is scanning the tomography of the power utilities while moving?
Yep.
So is it suitable if the vehicle is used off road, if used in maybe in a jungle or the road is quite bumpy? Does do uh, does it have effect on your data capture?
Oh, so like honestly, we haven't operated our solution in jungle because there's no jungle in
Mm-hmm.
South Korea. So, but however, there is a lot of like off-road in South Korea as well. Not a lot, but like is still some off-road or bumpy road, as you mentioned. So that's so in order for us to our solution to be operated without any problem while driving, we need to prevent vibration to get a clear IR image.
Okay,
Sorry,
you are
like
welcome to Kelantan, Yongsang.
sorry for that. Like communication is not connected well, I guess. So, Amir, are you still here? There?
Boleh ajak pergi Kelantan tu.
Boleh.
So, Amir, hello. So, where is Amir?
It's okay, James. I think you can proceed because I think Amiru is having problem with the connectivity. I think.
All right. So, someone just like let him know that we have an anti-vibration plate behind our solution. So that support measuring unit, so that like that prevent like vehicle from getting affected by vibration. We have an anti-vibration plate to prevent any vibration even in a off mode. So like
So before we start the on-site demonstration, sorry, James. Mr. Faris, this is the concept is the same as the Indis. So just different the technology, but the same concept. So while driving within 30 kilometer per hour, we can capture the all the poles what we passed. So that is the simple idea, same as the Indis.
Okay, right. By the way, you can just proceed because it's okay. Don't worry about people falling out of the conversation because I'm recording this conversation, what you call that, this session. So I will share with them our conversation after this with those people who had to miss your explanation just now. Okay,
Great.
so you can
Yep.
proceed. Okay, right.
Okay, thank you. James, can we move to the poll?
Oh, can you say that again, please? So,
James, can we move to the poll?
all right.
To inspect? Yeah.
So from now on, we're gonna actually operate our solution, and then I'm gonna share some screen over here. Just like before we operate a solution, we need to share the screen in our solution. So let me just seconds.
So Mr. Amirul is back
So
now.
gentlemen, can you all see the screen? I share the screen of our solution right now.
Yeah, I can say that. Yeah.
Okay, I can see. I
Yes,
can
yes,
see.
yes.
All right.
Okay, go on. Uish.
All right. Let us start to give you a demonstration from now on. Thank you so much for asking many questions. 이번에 말 안 할 거라고. 예, 말하다가 저번에 놓쳐가지고 말할까요?
뒤에다 놔. 아니야.
So right now, all right, let us start. Oh, so let me briefly explain basic information about the screen. So in the left bottom side, there is you can check communication status of our solution. If there is a green light blinking, which means communication is successfully connected, and then right side of the screen, there is GPS section where you can check real time GPS coordinate, latitude and longitude, and also if vehicle move drive, you can also see the driving speed as well over there. And then there is main IR screen, and then in the white and black screen is for the tracing electric facility by tracing the electric wire. Then there is below this screen there is analysis box over there. You can see the current status of the facility. Analysis result gonna be pop up whenever you take the IR image. And then there is pan and tilt section. There is compass where you can check which direction your measuring unit is facing right now. And then there is result and total result as well. All right, let us start to give you a demonstration, like diagnosis demonstration right now.
뒤를 찍고 있어요. 뒤를.
네네. Yeah.
James. Hello, James.
Yep.
Okay. When there is a problem, there will be a warning sound.
Yep. Can you hear any blinking sound, like little sound, whenever I just take a shot?
No.
Also in this touch screen, I can only hear, but you guys cannot hear. But if you operate this solution, everyone can hear whenever we take a shot. So there is a warning alarm sound as well. So yep, right. Let us continue to inspect this.
Apa cakap mesti? Keluar.